Okay, hi everyone, welcome back to Intro to iOS Development. We're going to be using Polo today, not the one that you downloaded from TestFlight, but the one on the App Store. So if you go to the App Store and you search for Polo, it should be like the second app option. So if you download it and like use this code, we'll be like asking a couple of review questions from that. Okay, first, a couple of logistics. We have the Hack Challenge opening ceremony tonight, so get excited for that. We're basically going to do team matching, go over like what our prizes are, and like a little bit of like what we expect from you from the projects. Attendance is required. Basically, we just want you to be there so that you can see everyone in the classes and potentially like meet your like project partners. We also wanted to advertise that we have a Git workshop. So a lot of you filled out the poll and said that you wanted to learn Git and GitHub. So we're actually hosting a workshop with URMC this Thursday from 5 to 6 p.m. in Phillips 101. So if you're interested in learning Git and GitHub, this would be like a really great opportunity for you to do so. Okay, so let's do some review. So open up Polo. The code is 19U535. And the question is, which of the following is not a type of HTTP request? And your options are get, create, delete, and post. And I'm going to get the question out. Does everyone see it on their phones if you have it? No? Oh no.
Are you guys on App Store?
Yeah, do you have like the App Store version? Oh no. Wait, let me try this again. Okay, do you see it now? Yeah. Okay, cool. Socket session was bad. All right, we'll give 10 more seconds. Okay, does anyone want to say what the answer is? Yeah. Create, good. So the answer is create. Basically, there is no create request. Usually, if you're trying to like create a user or like add something to a database, you actually use a post request. So there's no such thing as a create. But you can get, you can delete. Those are like valid HTTP methods. Does anyone have any questions? All right, cool. Next question. What is JSON? And then you'll have like 30 seconds to answer. Okay. Does someone want to share the answer? Anyone? You have a 25% chance. Yeah.
B.
B. Good. Can you explain why?
So JSON is like it says like value pairs, where
Mm-hmm.
the key is a string of some name, and then the value is some type.
Yeah.
Another string or array or another object.
Yeah, great. So a JSON is basically a dictionary of key value pairs, and the values can be arrays, but JSON itself is not an array. So just to make that distinction, JSON is itself like a dictionary with key value pairs. The key has to be a string, and then the value is like int, bool, string, array, object, etc. Does anyone have any questions about that? All right, cool. Let's move on. So let's talk a little bit about closures. So I know a lot of you did the extra credit assignment about closures, which kind of gives you a little bit of a look into what we'll be talking about. So closures are basically like self-contained blocks of functionality that you can pass around and use in your code, or like That's kind of the formal definition, but basically they're functions that aren't formally defined. So they can have, you can like store them as variables, and then you can like pass them around as functions in your code. But like you don't have to assign them as like func blank, and then it does something. So here's an example. So this is a variable or like a let constant that says add two numbers closure. And then you can see that the type is int, comma, int, arrow int, which means that this is a function that takes in a tuple of two integers and outputs an integer. And then it's saying, like, there's a curly bracket, which kind of symbolizes that it's a function. And then you can see first, comma, second. And this is basically defining the two arguments or the two integers. And then it says in return first plus second. So what this closure does is it takes in the two numbers and adds them together. So what exactly is the value of closure 3 based on kind of what I just explained about add two numbers closure? Does anyone want to guess? Yeah. 3, yeah. And the reason why is because add two numbers closure takes in two integers, 1 and 2. And basically 1 and 2 are going to be represented in like first, comma, second when you call the function. And then it's going to return the sum of 1 plus 2 because it's first plus second. And so you get 3 as a result in closure 3. So this basically, you're probably wondering, like, this is basically the same thing as writing a function that takes in two integers. So why is it different? You can also use it for some like really cool functionalities, especially with arrays. So you can see here, there's 3 functions that are kind of really useful in Swift. They're map, filter, and sort. And basically, map is a function that's used to get from a certain type to another type. And basically what it's saying is you want to apply a function for every value in the array, and then you'll end up with another array with like maybe different values. So we can see here we have a list constant that has like 5 numbers in it. And then if we call list.map, you can see that there's a closure here that it's of like with the variable num that represents each element in the list, and then it outputs a bool. So basically here we're saying if num is greater than or equal to 0, that's like what we're going to input into our mapped list. So if we go through list, it's basically saying negative 23 is not greater than or equal to 0, so we're going to have false in our mapped list. And then since 10 isn't greater than or equal to 0, we get true in our mapped list. And so on and so forth. So basically it loops through the list, applies this function to every element in the list, and returns that to you in a new variable. So basically you have to define how you want to convert this int into some sort of Boolean. Does anyone have any questions about that? Okay. Here's kind of an example of why we use closures in networking. So when we did networking last time, we basically just printed the JSON to the console of Xcode, but here we actually want to decode what we get from the internet into like an object so that we can actually display it like in a table view or in a collection view or anything on screen. And the way we do that is we can actually take the objects that we get from the internet, decode them as an object in Swift, and then we can then handle that appropriately. So for example here, we have this function called getClasses, and there's this thing called a completion, which is basically saying once I've actually gone to the internet, fetched the classes, and gotten the courses back, then this function is going to be called. And what this function type is course array to void, because what it's saying is this function is going to have an input that is of type course array, and then it doesn't return anything, so it's just void. And the reason why we do this is because getting information for the internet could take like instant, like it could be instant, but it could also take forever depending on your internet connection. And so that's why it's escaping. So that's saying like as soon as we get the information from the internet, then this function completion will be called, and it's going to actually return from this function itself, like this getClasses function. So here we can see we've made like our Alamo Fire request. It's a GET request, and then we get the JSON back. And then if it's a success, then we can see the JSON, whatever. And then this is where we would actually like decode the JSON to an array of courses. And let's say we store it in a variable called courses, so it's of type course array. And once we've done that, then we'll call the function that was input into our get classes function to appropriately like handle this new data. So for example, one thing we might need to do is like if we have a table view and the table view is associated with an array, we need to update that array in that view controller to maybe set like the courses to be, or set the variable in the table view to be equal to courses, and then we can do table view.reload data so that the table view will update based on that new information. This is kind of complicated. I'll try and explain it a little more as we do our demo, but you should just know that you can pass in functions as arguments to like your networking calls or any other function calls, and that way it's a lot easier to handle like asynchronous results. So asynchronous is like it's not happening one after the other because the internet takes some time for things to happen, and you don't know like reliably when you're going to receive a result back. That's why like this function will be called in the background when you get like information back. Does anyone have any questions about that? Okay, cool. So basically, I already kind of explained this, but you get like a response back from the internet after some period of time, which is why you have that first response in, like in the line 2. And then that's like an example of a closure, just like how when we call this function, we actually input a closure. Yeah, so basically we want to decode it. And the closure is a parameter to our function, which is called completion, and it'll be called with our updated course array. And then, as I said before, like a closure can be escaping, and that's basically saying it can escape a function when it is a parameter, and then it's called after the function returns. And you don't really need to worry about like why exactly it's called escaping. You just need to know like we use escaping closures when we make calls to the internet. Okay, a little bit of review for networking. So as I said before, it's used to like retrieve or update, add, delete data from the internet. For example, like if you're getting all the information of all the posts in a feed, if you're like logging into something on the internet, maybe you're like deleting a song from a playlist. So the first one is like an example of a GET request. The second one is an example of like a POST request, and then deleting a song from a playlist would be an example of like a DELETE request. And basically, we use this because we want data to persist like on the internet instead of just like locally on our phone. So then we can like store stuff in like a database on the cloud and get information that way. And then another thing is sometimes you need to pass in information to these network requests. So for example, if you're searching for something, right, you can't just hit like the search endpoint because that doesn't really make sense. You need to say like, oh, I'm searching for like music, or I'm searching for like Game of Thrones. So that's why you would need to pass in information. Or another example is maybe you're like signing up as a new user, so you have to provide your personal information like your email address, like maybe your password, like your first name and last name, something like that. Or when you're like logging in, you also need to pass in like your username and password. So these are all examples of sending in parameters to a network request, kind of like how you have to send in parameters to a function like locally on Swift. So there's like a bunch of encoding methods. So the three most common ones are query string, HTTP body, and JSON encoding. So the first one is typically used for GET requests. So for example, if you are like making a request for like searching for dogs on the internet and you want the first page of results, your parameters would be kind of like a dictionary. So you have two arguments, query, which maps to a string called dogs, and then page, which maps to 1. And then this is actually, the query string would look like in the URL, like getrequest.com/whatever, /search, and then it would be ampersand query equals dogs, ampersand page equals 1. So this is actually how it would like load on the internet. You've probably seen this in like your URL address bar on your browser. That's basically how the format looks. Another version is HTTP body. So the parameters passed are in the form of like that same ampersand equals format, but they're in like the body of your post request. And then another example is JSON encoding, which basically sends the arguments in the form of a JSON. So it's just like we've seen before. It's a dictionary of username, comma, Mike, password, Dink, and Flicka. And so HTTP body and JSON encoding are more common, or it's basically standard for those to be for post requests. And the URL encoding.default / JSON encoding.default are like the Alamo Fire arguments that you'll need to use in Swift. Another side note, so we might have mentioned API before, or you've probably seen it on the Hack Challenge proposal. API stands for Application Programming Interface. So it's basically like a menu with operations that your application can use to interact with like another application. So for example, if you're using, or Google, you can use like Google Calendar, but maybe you want to like embed or like get information from Google Calendar into your own app. You can look up their Calendar API and it'll list all of the HTTP requests you can make to their server and like what kinds of responses you'll get back. And then, for example, this might allow you to add events to Google Calendar from your own application. Does anyone have any questions about APIs? Okay, cool. So now let's talk about how we actually go about decoding the responses from the internet. So when you make a request to the server, as we've seen before, we use like Alamo Fire, which is our library for networking. This example is basically making a GET request. We validate it so that it's like correct. Then we get the response back. And then there's like two cases, like if it succeeds or if it fails. But how do we actually take that JSON, turn it into a Swift object, and display it on our app? So let's say we have this example that we used last week. We're going to continue using this week, where we have like a giant JSON. There's like it's like a JSON with the argument data mapped to an object or like an array of classes. And basically each class has a name, a code, an instructor, and a Boolean for whether or not you're enrolled. So you can see that there's kind of a pattern here. Each class has 4 fields, and you know the type, right? So name is a string, code is an int, instructor is a string, and enrolled is a Boolean. So we can actually create a corresponding Swift object. So how do we actually do that? We basically use a struct, or we can use like a class, up to you, but I think it's easier to use a struct. And basically you can create a struct for course with all of the variables for name, code, instructor, and enrolled with the corresponding types in Swift. And then once we've done this, we actually have to conform it to a protocol called Codable. And basically what this does is it allows you to use something called a JSON decoder to convert this JSON into an array of into course objects. So it's really cool because all you have to do is like write a couple of lines of code and your JSON automatically turns into like an array of courses in this example. So notice that the field names and types have to match exactly, or else you're going to get some decoding errors. So you just have to be careful, especially when you're maybe interacting with your backend developers, that like the variables match exactly. Because if you have like one typo or anything, your app is going to crash because you're going to get a decoding error. Okay, so let's do a demo of how this works. So open up your Lecture 7 starter. Okay. Sorry about that. Okay, so as we've seen, it's basically the same code from Lecture 6. And what we want to do now is make our actual network request and not just print it, but actually decode it into a course. So you probably have this struct, or this file called course.swift. It has the struct already. So each course has a name, code, an instructor, and a Boolean for whether or not you're enrolled. So what we actually want to do is, in order to decode it from the internet, what do we have to make our model conform to? Does anyone remember? Yeah. Codable, yeah. So it's going to be struct course inherits from Codable. And so once we've done this, now we can actually think about how we want to decode our courses from the internet. So if you remember, let's see. So if you remember, we have like this kind of JSON from the internet, and you notice how there's this thing called data, and this data maps to a dictionary with classes, and the classes maps to the array of course objects. So we actually have to extract out the data and the classes first, and how we can do this is we can actually model the course response, which has an argument called data, and it maps to this other response, which maps classes to an array of course objects. So let's first start by creating a model for this classes to course array. And we can make a new struct, and we can call it course data response. And we're going to make it codable. And so basically, as we've seen here, classes maps to an array of course objects. So we want to make this argument, or this variable, classes, and it's going to map to an array of courses. And so once we've done that, now we want to make the top level response. So this is a data variable, and this variable is going to map to our actual object here that we just created, because the object that we created has a variable called classes, which maps to our course object. So we're going to make another struct, and we're going to call it course response, and we're going to make it codable. And here, as I mentioned before, since there's a key called data here, we're going to make a variable called data, and we're going to map it to the course data response. And so now we can actually decode our entire response to this type, course response. So now if we go into our network manager, so basically we have to rewrite the Alamo-fire call that we did last week. Does anyone remember how to start it? Or anyone want to make a guess? It's like Alamo-fire dot. Does anyone know? Okay, so I'll just remind you, it's Alamo-fire dot request, and then you'll see the first like autocomplete. You can press enter for that, and so you want to make a request to a certain URL, and we're going to make a request to the endpoint. Since we're getting information from this JSON, what method are we like doing here? Get? Yeah. Because we're getting information from the internet, we're not like posting, or we're not deleting anything. Here we don't need any parameters, so we can actually delete this entire argument. And then we actually don't need any of these as well. So you can just delete these. So we're making a GET request to this endpoint. We're going to validate it. And then we're going to get the response data back. And you can see here, this is a completion handler. And what it's saying is we want to pass in an argument to this completion that is of type data response, and the return type is void. So this is basically saying this Alamo-fire request is going to deliver back some response. And then here we can define what we actually want to do with this response. So if we double click on that, you'll get this format. And then you can delete this argument and the parentheses, and you can replace it with our variable that defines what we actually get back from this Alamo-fire request. So now the response can have two different outcomes. So we can switch on the results. And the result is an enum. So there's two cases. We get a success, and the success can contain a value called data. And then we also have a case for failure, and then there's going to be an error. And for the failure case, we can just print the error localized description. Okay, so for this success case, that says that, oh, we're actually getting some sort of data back from our network request. So let's try decoding it. So in order to decode it, we have to create a JSON decoder object. So we can do JSON decoder equals capital JSON decoder. So this basically creates the object that will decode our response from the internet. And then now we can actually try decoding it. So we can do if let course response equals try JSON decoder dot decode of type. So we basically, what this is asking is the JSON decoder is going to try and decode the data from the response into some sort of class that conforms to decodable. So since we created a struct called course response, we can actually try and see if this JSON decoder can decode our data into the type course response. And then you just have to add .self at the end, and we're going to try and decode it from this data. And the reason why we have an if let and a try is because, for example, if the decoder fails because it's missing arguments, or it can't successfully match the information from the endpoint, that would be a case where this would fail and you would want to maybe like print an error. And that's why it's try with a question mark, so that means it's going to return an optional type, which is why we wrap it in an if let, because if course response exists, then we can operate on the course response. Does anyone have any questions so far? Okay. So now we can get the classes out of the course response. So let's say, basically the course response has a field called data, right? And this data field has a variable called classes. Because if you remember in this JSON, there's a variable called data, the data maps to a variable called classes, and the classes are the actual array of course objects. So now that we've got the classes, we can call our completion handler on the classes. And what this is saying is, once I've actually successfully decoded all of this, first I've gotten all the information from the internet, now I've actually decoded it from the internet, I'm finally going to pass this off into the input to this function, which is kind of, it might not be intuitive at first because it's, you think like this is an argument to the function, so why am I calling it here? But since completion is a function, you can call the function whenever you want in the body of your actual function itself. So now that we've done this, let's handle like the else case where the decoder maybe fails. We can print just a string like invalid response data. Okay, so now that we've done this, we can actually call our network manager function. So if we go back into view controller, we have this, we're calling this in viewDidLoad, but currently getClasses does nothing. So in order to call this function, we're going to do network manager dot getClasses, and you can see here that it takes in an argument called completion of type course to void. And what this is saying is basically once getClasses is called, the network manager is going to make this Alamo fire request. It's going to get either a success or a failure. If it gets a success, it's going to try and decode the data. Once it's finally decoded it, it'll actually hand off the classes it got back right into this function, or right into this variable. So as a reminder, if you want to like complete this completion, you just double click on this blue box, and then we can name the variable that represents our array of courses. So we can call it courses. And now, since we have our array of courses, we can do self.courses equals courses. And then we need to reload the table view, right? Because the table view is associated with this array, and right now there's no courses. So we want it to update based on the information we got back from the internet. And the way we do that is we actually have to call this on the main thread. And this is basically because this function call is happening in the background of your app. Because if this happened in the front of your app, as soon as you clicked a button to get something from the internet, the app would freeze completely. And we don't want that. But however, we need the UI to be done as fast as possible so that the user can have a nice intuitive experience. So the way to do that is basically dispatch queue.main.async. And then here is where we would do self.tableview.reload data. So this is basically saying as fast as possible, I want this table view to be reloaded and updated because it's a UI element. Does anyone have any question about that? Okay, cool. So now that we have this, we can actually run our code. So let's try running it. So if you have, I don't know if you've tried using breakpoints, or maybe you've accidentally clicked on the line numbers over here and gotten these blue arrows. What these are breakpoints, and essentially what they do is they kind of pause your code right when it's running, and it will basically freeze everything that is happening at that point. So I just want to show an example of how that works. So let's say we want the app to pause here, and we want the app to pause actually when we're in this function body. So intuitively, you'd think that lines 55 and 56 would run one after the other, but however, this courses array isn't going to be returned instantaneously. So we have to, or wait, let me explain. Yeah, so here we can see it's paused at this breakpoint, and what it's basically saying is I have not made this call to get classes yet. So one really cool thing about breakpoints in Xcode is you can actually print out stuff in this little box here. LLDB is a version of a debugger, and you can print out variables. And the way you can do that is you do PO space the name of the variable. And you can see over here in this left box that you can see all of the UI variables and elements here. So let's say I wanted to see the courses array. So I could do PO courses. And we can see that it's an array with 0 elements, right? Because we haven't actually made the networking call to get the classes from the internet. Okay, so that means that we're about to get the classes. So if you want to resume your code from running, you can press this little play button here that says continue program execution. And we can see here it loaded the view, but it actually took some time to run self.courses equals courses. And the reason why is because it had to go to the internet, it had to fetch the success, it had to decode the data, and then give courses back. So if we see here, if I print out courses again, so if I print out courses, we actually have 0 elements. But this array, if you hover over it, we can see that there are 8 values in here from the internet. So this is the successfully decoded information. And now we can actually set the courses variable to match the one from the internet. And once we've done that, we'll reload the data of the table view, and we'll see that the shopping cart actually shows up with all of our enrolled courses. So to reiterate, so if I add a breakpoint, let's say in this function, we'll see that this doesn't, or you'll see the order of how things work. So if I rerun the code, So we'll first see that the function first pauses here at where networkmanager.getClasses, but you would expect it to immediately go to line 56, but if I click the play button, it actually stops here. So that's saying we're at the point where we're getting the information from the internet, we can decode it, etc. And then finally, we'll get to this line where it says completion classes, and this is where if I had a breakpoint here and I click play, we'll see that the classes are the same like course objects that we've seen previously. But then this function then leads to, if I click the play button, it leads to this line, self.courses equals courses. So this function, or this variable, is only supplied after it's gone to the internet and decoded the information. So now we can set it to the variable in our view controller. Does anyone have any questions about that? Okay, cool. Another quick thing I wanted to show you in Xcode is maybe you're having like constraint issues with your UI elements, or you just want to know like where things are on screen. One really cool tool is this like view debugger. So if you see like these 3 rectangles here in this left corner and you click on it, it'll actually load all the elements that you see on screen. So this is really cool because if you like tilt it, you can see kind of the stack of how things are added to the screen. And let's say like if you want to zoom in on a cell, you can see like, oh, like the label is here or whatever, like each one of these. Yeah, so it's cool. So like let's say you don't know if something is showing up or not, this is a really great way to see like whether or not like you made the constraints correctly, and stuff like that. Oh god. Yeah. Does anyone have any questions about that? Okay, cool. And then one last thing, so if you want to delete these breakpoints, you basically just drag them off the line numbers, and you can see all of the breakpoints that you've made on this little like blue arrow looking thing. And you can just see where you've made them, and you can delete them or whatever. Okay, so now let's try making a different kind of request. So you can see here that we have this function called login, which was going to make a request to this website. And basically what this website is it hosts a bunch of like test URLs that you might want to try out. So this is an example of like a fake login endpoint. Obviously you wouldn't just like send this through the internet because it's kind of unsafe, but like this is a test, so it's fine. So we can see that the endpoint is API or /API/login, and the supplied arguments that we need to give to the endpoint is email and password, and they're both strings. And the response that we get back is token, and then it's going to match some sort of string. And we can see here that it's a post request. So let's try making this request. So once again, we're going to do alamofire.request. But before we actually make the request, we need to set up the parameters. So as you can see here, we need to supply an email and a password, and the way we do that is in the form of a dictionary. So we can do let parameters, and it's of type string to any, and then we can make a dictionary. And the first argument is email, and it maps to the input to the function, and then password, which maps to the password. So now we can make a request to our post endpoint. The method we're going to do is .post, and now we actually have parameters, so we can feed those into the request. And then the encoding here is going to be URL encoding.default. And then we don't have any headers, so we can delete that. So once we've made this request, we're going to validate it, and then we're going to get the response data back. So once again, we need to handle when we get back the information from the Alamo fire request. So we double click on this and get response. Okay, so now once again we have the response result. So we basically have two cases of success and failure again. So I'm just going to copy and paste this right here. And then we can delete the stuff inside the decoding part. So as you see in this kind of API specification, we get back this thing for token, and that token maps to a string. So we can just create a struct. I'm just going to make it in this file, but ideally you'd want like a new Swift file for each one. So we can call it struct user, conforms to type Codable. And as we can see here, it's a string the variable is token, and it's going to map to a type string. So token to string. So now, once we've created our JSON decoder, we can do if let response equals try or JSON decoder dot decode. So now we're decoding based on this user struct. So we're decoding user.self from the data. And so once we've gotten this response, we can basically just print received user with token. And then remember that you can insert variables into strings like with this backslash parentheses. So we can do response.token. So once we have this, we can like give it a shot by just logging in from our view controller. And the way that we can do that is, if we go back to view controller, you'll see that we have this function called for get classes. But now let's say we want to log in. So we can create a function for that. So func login with an email of type string and a password of type string. And here we're going to do network manager dot login with the email and password. And typically you would have more lines of code similar to like the get classes one, because you'd actually take that information and send it to the UI or something like that. But since this is like not really logging you in or doing anything, it's just kind of short. So now let's actually call this from view did load. So we can do login, and then you can use any string you want because this isn't like an actual login application. So hello at 123.com, password abc123. Don't make that your password in real life, but yeah. So once we call this login function, I'm going to make a breakpoint here. And then I'm also going to call or create a breakpoint in this like success portion. And then we can try running it. So basically what we want to see is that the network manager.login is called. So you can see that it's called here. And then it goes into the body of the function. So if I press play, you can see that it's paused here. So you can actually see in the simulator that the courses have already been loaded, but this response back from login hasn't. So that's something interesting to note, I guess. So we can see that we've made our post request and we've gotten the response back, and then we've decoded the response, and we'll soon see in the kind of bottom here, received user with token QP whatever. Yeah. So that's an example of making a post request with Alamo Fire. I'm just going to delete these breakpoints. Okay, and then let's do one more example of a network call. This one is going to basically get random dogs from the internet and also fetch its image. And the way you do that is basically we're going to use this API called like random.dog. So this is like the woof.json, but if you go to like random.dog, you basically load like a bunch of dog images every time. It's pretty fun. Yeah, so there's like a bunch of different APIs that you can use. So woof.json is basically giving you a URL to an image of a dog. And basically if you like copy and paste this into like a new browser window, it'll just give you like an image, which is pretty great. Okay, so how do we get this dog from the internet? Let's make the GET request to first get the random dog. So, hold on. Alright, let's get the dog endpoint. So, first we're going to do alamofire.request. So we're going to make a request to our dog endpoint. And we actually, by default, the default method is going to be a get, which is why you can also do this as shorthand. So then we can validate it, get the response data, press enter, so we get the response back. And now we have to do the whole like switching on the response.result. So I'm just going to copy and paste that in. So now we actually have a new struct that we have to create, right? Because the response back from woof.json is URL maps to the value of a string that's technically a URL. And so the way we are going to model that is we're going to create a new struct. Let's call it dog. We're going to conform it to Codable. And since there's a key for URL, we're going to do var URL, and it's going to map to a string. So once we've done that, we're going to go back to here, and let's say if let dog equals try, JSON decoder.decode, and then what are we going to try and decode it as this time? Instead of user, does anyone want to guess how, like what object or what class we want to decode from? Dog, yeah. And so we're going to decode the dog from data, and then instead of doing something there, we're actually going to try and get the dog image from the internet. So you can see here that we have this function called fetchDogImage, and the reason why we have to make another request to get the image is because when we make this GET request, we only get this string, that's the URL, but in order to actually get the information from the URL, we have to make another GET request. And so the way we're going to do that is we're going to do, let's see, so we're going to make another alamofire request. So alamofire.request, and we're going to do from this image URL, we're going to validate it, get the response data, and then we're going to get the response back. And then here, once again, we have to do like the case success, case failure. So I'm just going to copy and paste this. And instead of actually decoding it, since you get an image back, we're going to try and load this image as a UI image, and then we're going to pass it into this completion. And so what this is saying is like once we've successfully gotten the image from the internet, we want to make it or convert it to a UI image and then give it back to whoever called this function, or basically to this completion. And so the way you turn data to a UI image is if let dog image equals UI image. And then when you open the parentheses, you can see there's this option for data. So basically, it'll take the data that you get back from the internet and try and convert it to a UI image. And it'll return an optional image because you might not be able to decode the data to an image. So once we've gotten the dog image back, we're going to call this completion function and hand the dog image back to the completion. So now, if we go into here, we're going to do fetch dog image. So we're gonna get the dog's image URL. So it's gonna be dog.url. And then there's a completion function here. But we haven't defined like what we want to do with this UI image. And ideally we want this UI image to be displayed in a UI image view that's gonna exist on our view controller. So if you see here, we've already made a dog image view in viewDidLoad. We've set up the constraints. But we actually need to set the image. So first, let's actually think about what we want to do to our network manager so that we can pass this image back to the view controller. So we actually need to make a completion handler here that'll take in a UI image and then output void. So we're going to make a completion. It's going to be escaping, and it's going to take in a UI image. And it doesn't return anything. And the reason why we're doing this is because when we call this function, we want the view controller to be able to receive the image back, set the image views.image, and then like that's it basically. And we want it to display. So here, instead of like double clicking on this and defining what the completion actually does, we actually have to define what the completion does in the view controller, because we're accessing variables from the view controller. So here we pass in the actual completion that we defined here. So the completion is going to be completion. Okay, so once we've done that, now we can go back to view controller and we can create a function called getRandomDog. And we can do network manager dot getRandomDog, and here there's the completion that we specified earlier. So if we double click on this, it's going to return back an image. And what we want to do is, since we want to update the UI, we have to do dispatch_queue.main.async, and we want to do self.dogImageView.image equals image. So here it's going to set the image property of the image view to the image we actually got back from the internet. So to show this once again, I'm going to make some breakpoints just so you can see kind of how this works. So we can run it.
Did you call the function?
Oh, no I didn't. Oh wait, my bad. Why didn't any of the breakpoints run? Does anyone know? Does anyone want to guess? Yeah.
You didn't call it?
Yeah, great. So I actually didn't call getRandomDog in viewDidLoad, so it's never going to be called. So let's run it again. So we can see it's paused here at the call for getRandomDog. And if I click play, it'll first go to this function called getRandomDog. It's going to make the request to the dog endpoint. It's going to get the data from the dog endpoint. It's going to be a success. We're going to get data back. And now we're going to try and decode the dog into a struct. And now it's actually finally fetching the dog image. We've received the image from our GET request. We have successfully converted it to an image. And now we're going to hand this back to the dog, or back to the view controller. So if I click play, now we can see we've received the image back. And now we can set the dog image view accordingly. So now we have a dog here. And then we're running out of time, so I'm going to go through this last part really quickly. But if you want to like make a timer that gets random dogs, you can basically do... we've defined this variable called timer, which is of type timer up here. And what you can do is... you can do timer equals timer.schedule-timer, and it's going to be time interval, let's say every 3 seconds. It's going to be kind of like a button, so we want the getDogImage function to be called every 3 seconds. And then we can set user info to nil, and then it's going to repeat. And so basically what this does is it's going to call getRandomDog, kind of like clicking on a button will achieve some result. This timer will call this function every 3 seconds. And then if I remove these breakpoints, we can see we've got a dog, and it'll switch every 3 seconds. So yeah. All right. Last couple of things. Basically, we're starting the Hack Challenge ceremony soon, so stay here. We're gonna hand out red name tags because you all are in the iOS course, so take it and write your name on it. And yeah, if you have any questions, come see us.
We're starting the Hack Challenge, but we still have lectures for the next 2 weeks. Just a reminder.
Yeah.